Okay, so in this lesson we're going to talk about equations that are called conditional equations, or identities, or contradictions. And so we're going to focus here on linear equations, since that is our focus on these lessons. So let's get that first statement. So the solution to an equation are the values of x that make the equation a true statement. So when we solved equations in previous lessons, you saw what we meant by finding the solution to an equation. A linear equation in one variable has one unique solution. So one unique meaning no other solution is there. It's just one solution. So let's look at this example that you can easily solve. So to solve this linear equation, I'm going to use properties of equality. So I'm going to add 1 to both sides. And so when I do that, I get 2x equal 5 plus 1 is 6. And then dividing both sides by 2, I get x to be 3. So that is my one unique solution. So that is your solution, and there is no other solution. It's just that one. Okay? So that's what we mean by a unique solution. But there are some linear equations, that will not have one solution. They may have no solution, while others have an infinite number of solutions. Okay? So let's talk about these words up here in relation to the solutions to these linear equations. Okay, so the first one I want to look at is what we mean by a conditional equation. So a conditional equation is defined this way. Your textbook defines it this way. An equation that is true for some values of the variable but false for other values. All right, so for example, if I look at this very simple example, all right, x plus 3 equals 7. So this linear equation is true for x equal, was that 4? 4 plus 3 is 7. But false for other values, right? Other values. So for example, x equal 6 is not a solution because 6 plus 3 does not equal 7. 6 plus 3 is 9. So this equation that has this one solution is called a conditional equation. So this is an example of a conditional equation. So in a conditional equation is where the equation is true for some values of the variable but false for other values. So this equation is true only for x equal 4 and false for everything else, every other number. Okay? So that's a conditional equation. So now let's look at a contradiction. What do we mean by a contradiction? Okay, so a contradiction, and some textbooks will use the word inconsistent equation, so keep that in mind. Your textbook uses the word contradiction, but others could use the word inconsistent. All right, inconsistent equation. And a contradiction is an equation that has no solution. All right, so what that means, if an equation has no solution, this is what that means. There is no value of x that will make the equation a true statement. No value of x that will make the equation a true statement. So for example, let's look at a very simple example. So the following is an equation that is called a contradiction. So x plus 2 equals x plus 5. Okay? Can you look at the value of x? Can you think of a value of x that will make the left side equal to the right side? All right? So notice that this equation, there is no value of x in which x plus 2 equals x plus 5. A number plus 2 plus that is not equal to that same number plus 5. So there is no value of x that will make x plus 2 equal x plus 5. So this equation is called a contradiction. All right, that equation is called a contradiction. Now, let's go ahead and solve this. So let's go ahead and solve this to show you what's going to happen. So if you have a contradiction, if you have an equation that's a contradiction or an inconsistent equation, this is what's going to happen. So keep this in mind. So I'm going to rewrite this over. X plus 2 equals x plus 5. If I subtract x from both sides, I want you to notice what happens to the variable. So x minus x is 0. You get 0 plus 2 is 2 equal x minus 0 is 0. And 0 plus 5 is 5. Notice the variable disappears. There's no longer a variable. But notice the statement, 2 equal 5, this is a false statement. This is a false statement. And so what that means is that, this means that there is no value of x that will make the equation a true statement. Okay? So this right here is pretty easy. This equation is pretty easy to see that there was no solution, but sometimes you actually have to work it out to see what statement you end up with. So notice the variables disappear. Okay? That's important to see. The variables disappear, and that statement you have is a false statement. 2 is not equal to 5. That's a false statement. So that means that this equation has no solution. Okay? So there's no solution. So this equation has no solution. Okay? So that equation has no solution. So an equation that has no solution, is called a contradiction. That's called a contradiction. Now, so one way to, so you'll be asked about the solution. What is the solution? So you say the solution is, and you could do one of two things. You could say there is no solution, or you could use the empty set symbol. So here's the empty set symbol. It's that 0 or a circle with a line through it. So that's the empty set right here. So that's how you would represent a solution. So you could say no solution, or you could use the empty set symbol. Okay? Or if you want to, you could just do something like this, just a brace with no number in it. Okay? So if you use a brace with no number in it, like this, then that means the empty set. So no solution, you can write the word empty set, or you can do this. All right, so this is a set with no numbers. So that means the empty set. All right, so that is what we mean by a contradiction. Okay. Now the next thing we're going to look at is the identity. What do we mean by an identity? Okay, so identities. An identity is an equation that has all real numbers as its solution. An identity is an equation that has all real numbers as its solution. Okay, so far we know this. We know that a contradiction is an equation that has no solution. A conditional equation is an equation, let me go ahead and read this one. A conditional equation is an equation that is true for some values of the variable but false for others. Okay, but an identity is an equation that's true for all real numbers. All real numbers. That's what an identity is. So for example, we can look at a simple example. So this is an example of an identity. So x plus 3 equals x plus 3. Okay, so notice the left side is identical to the right side, correct? Here's the word identity, identical. The left side is identical to the right side. So no matter what you substitute for x, it's going to be a solution. So for example, if x is 5, look at what we get. 5 plus 3 equals 5 plus 3. That's a true statement in it. And the same thing for any other number. So this works for all real numbers. So this equation, the solution, so the solution to x plus 3 equal x plus 3 is all real numbers. So that's how you would indicate the solution. So that's an identity. So x plus 3 equals x plus 3 is an identity. Okay, so an identity is an equation that's true for all real numbers. Now, let me show you something. You remember when we looked at the contradiction, and we solved for x, just like we did here, and we ended up with 2 equal 5, and we saw that was a false statement. Let me show you what happens if you solve for x here. So if I subtract x from all parts, right, the x's cancel out, so you get 3 equal and then 3. Notice 3 equals 3 this time. That's a true statement. So when you get a true statement with the variables disappear and you get a true statement, then this means the solution is all real numbers. Okay? Solution is all real numbers. All right, so that's an identity. All right, so let's look at some examples then, where you have to determine whether the equation's a conditional equation, a contradiction, or an identity. Okay, so in each of the problem, the direction says this: solve the equation and then identify whether the equation is a conditional equation, a contradiction, or an identity. All right, so first of all, let's go ahead and solve this. So we have this equation, and so to solve this linear equation, I'm going to use the properties of equality. So I'm going to go ahead and subtract 3x from both sides. And when I do that, I get 4x minus 3x is x. So I get x plus 9 equal, this is 0, so I get negative 4. Subtracting 9 from both sides, combining like terms, we get x to be a negative 4 and a negative 9 is a negative 13. So that's my solution. Okay? Now, how many solutions do you have? So think about what we meant by conditional, contradiction, and identity. So notice that this equation here is true for this, but false for everything else, right? So those words came from which one? Those words came from conditional equation, an equation that is true for some, but false for others. So this equation is true only under condition that x equals negative 13. So then you would say, so 4x plus 9 equals 3x minus 4 is a conditional equation. All right, so that was number 1. Okay, let's look at number 2. So in number 2, let's suppose we had this for number 2. We had 6x minus 7 equals 2 times 3x minus 4 plus 1. So 6x minus 7 equals 2 times 3x minus 4 plus 1. So let's go ahead and solve this equation. So to solve this equation, I'm going to go ahead and distribute first. So I get 6x minus 7 equals 2 times 3x is 6x. 2 times a negative 4 is a negative 8 plus 1. Combining like terms, I get 6x minus 7 equals, and then 6x and a negative 8 plus 1 is a negative 7. And then notice right away that those sides are identical. So what that means is that no matter what number I substitute for x, the left side will equal the right side, right? And if you go further with this, if you subtract 6x, notice that the variables disappear. So that's 0, and you get negative 7 equal negative 7. So that's a true statement, right? That's true. So this means that the solution to this equation is all real numbers. All real numbers. Okay? And what that means is also that this means that the equation up here, this right here, the original equation, let me go ahead and write it. This means that 6x minus 7 equals 2 times 3x minus 4 plus 1 is an identity. All right? But it was important for you to see that this right here, 6x minus 7 equals 6x minus 7, that those two sides are identical. Right? So right away you know it's an identity, and right away you know that no matter what value I substitute for x, is going to be a solution. So the solution is all real numbers. All right, so that was number 2. All right, let's look at number 3. So number 3, we have this for number 3. All right, number 3. All right, we have, let's see, 4 times 3t plus 2 minus 1 equals 12t minus 4. So 4 times 3t plus 2 minus 1 equals 12t minus 4. So let's go ahead and use the distributive property. So I get 4 times 3t is 12t. 4 times 2 is 8. Minus 1 equals 12t minus 4. Combining like terms, 8 and a negative 1 is a positive 7. So I get 12t plus 7 equals 12t minus 4. And then notice that the variable terms are the same, but the constants are different. So you know what's going to happen, right? So you know that when you subtract 12t from both sides, that you're going to end up with 7, this is 0, and this is 0, is going to equal negative 4, which is a false statement, right? That's false. So you know what that means. This means, in terms of solutions, so this means that the equation has no solution. There is no solution. So this equation has no solution. So that means, in terms of the other part you have to answer, is this equation a conditional equation, a contradiction, or an identity? So since there's no solutions, there's no solution, this is a contradiction. So the equation is a contradiction. And then sometimes you may see the word an inconsistent equation or inconsistent equation. All right, so that's number 3. Okay, let's look at number 4. So number 4, let's suppose we had this, 5x minus 3 equal 6x plus 2 minus x. So first of all, let's go ahead and combine like terms on this side. So let's go ahead and solve this. So I get 5x minus 3 equal 6x minus x is what? 5x plus 2? So right away, same thing, right? So notice that the variable terms are the same, 5x on both sides, but the constants are different. So you know what's going to happen when you subtract 5x on both sides. You get negative 3 equal 2, which is a false statement. So in terms of solution, what does that mean? What's your solution? So solution is no solution, right? No solution. Okay, now another way you can say this, by the way, since there's no solution, you could say this. You could say the empty set, that, or you can say brace with nothing in it. All right, so anyone. But most students will either use the words no solution or they'll use a symbol for empty set. Now, since there's no solution, what kind of equation is this? Is it a conditional, inconsistent, or conditional, identity, or a contradiction? This is a contradiction. So the equation is a contradiction. All right, and then finally number 5. Let's look at one more. So number 5. Let's suppose we had this. We had 2 times x minus 3 equals 4x plus 7. Let's do that one. All right. So let's go ahead and solve this equation. So we're going to distribute the 2. So I got 2x minus 6 equals 4x plus 7. Solving for x, I'm going to subtract 2x from both sides. So this is 0. I get negative 6 equals 4x minus 2x is 2x plus 7. Subtract 7 from both sides. A negative 7 and a negative 6 is a negative 13 equals 2x. This is 0. Divide both sides by 2. I get x to be negative 13 halves. So that's your solution. So the solution is this. So this is your solution. Okay? So is this a conditional equation, an identity, or a contradiction? First of all, you know it's not a contradiction. A contradiction is no solution. You have a solution. An identity is where the solution is any real number. but this equation has how many solutions? It only has one solution. So since it has one solution, this equation, so the equation is a conditional equation. So this equation is true only in the condition, under the condition that x is this number. All right, so that is, and that's very simple. It's not a difficult process, but that is our lesson on conditional equations, identities, and contradictions.